Alright, so we're going to start with these notes over literal equations. So literal equations are just equations that have more than one type of variable. So you're still going to solve them in a similar way that you would when we were previously solving regular equations before, where you try to isolate a variable or a number to one side of the equation. So in this case, we're going to be isolating whatever variable it is that they specify in the question. So the first one says solve for W. So 15 equals 4W. 4 times W is what we have on the right side. So just like when we have a normal equation, we're going to try to get rid of that 4, and to get rid of it, you have to do the opposite. So if we have 4 times W, then to get rid of it, we would do the opposite, and we would divide by 4. We do that on both sides. Okay, so then that will cancel this out, and then we get our answer, 15/4 equals W. Okay, so then the next one, okay, so A equals L times W. So now we don't have any numbers, but you still solve it the same way, right? So your goal is still to isolate W, and in this case, the only difference between the first example and this one is that there's all variables, but you still get rid of L in the same fashion. So L is multiplying by W, so you do an inverse or opposite operation, which would be to divide by L on each side. Okay, so then W is just A over L. Okay, and that is it. So next one says solve for Y. Okay, so we have 4x plus y equals 10. Okay, so this one we're going to have to get rid of the 4x that is on the same side as y. Okay, so this is kind of similar to what we've done in the past. So that means that our first thing that we have to do is figure out what operation that is. So in this case, 4x is adding to y, so the opposite operation of that is not to multiply or divide this time. Now we're actually going to subtract 4x from each side. Okay, so then that gets rid of it on the left side. Remember, 10 and 4x, they do not have a common variable, so they are not like terms, so they don't combine, so they just stay separate. So your answer just ends up being y equals negative 4x plus 10. Okay. Then this last one, solve for y again. Kind of the same idea, right? The only difference is the one on the left had a number, kind of looks like what you're used to. The one on the right is all a bunch of variables, okay? But you still do the exact same thing, right? So RT is adding to y, so to get rid of it, you do the opposite, which would be to subtract RT from each side. So we do minus RT on both sides of our equation, so that this cancels out. Y is now by itself, which is what we want. And then you can either put W minus RT or negative RT plus W. It really doesn't matter. So I'm just going to put W minus RT. Okay. So now let's go ahead and get into some other examples here. So let's go ahead and scroll down. Okay. Here we go. So I'm just going to do the odd examples on this. So for the first one, solve for L, same idea, right? You're trying to get L by itself. Now this time W is subtracting from L. So if I want to get rid of W, I'm going to have to do the opposite, which means I'm going to have to add W to both sides. Okay, so then that cancels this out. So now I just have A plus W is equal to L. Okay, pretty straightforward. Number 3, we're solving for T. So this time, that means we're trying to get rid of R. Okay, and R is multiplying times T. So in order to get rid of it, again, you do the opposite. So the opposite of multiplying would be to divide by R. Okay, so then we get D over R equals T. Okay. And then number 5, so it says solve for r. We have p equals IRT. Okay, now in this case, we want to get r as the only one on this right side. Okay, and there are 2 different variables, but they're both just multiplying by it. So if I want to get rid of those, again, you would just divide. Okay, and you don't need to do them separately. You can just do divide by I and t. Okay, so we're going to divide by I, t. Okay, so we get p over IT equals r. Okay, because again, your goal is just isolating the whatever variable they specify on the one side. All right, so let's look at some other examples. All right, so number 7 says solve for h. Okay, so now we're looking at having to do 2 steps, because notice now on this one, we have 2b, which is adding, but then we also have p, which is multiplying times h. So we have to get rid of both. So this is going to be a 2-step equation. Okay, and our goal is to get h by itself. So I want to get rid of this, and I want to get rid of p. Okay, so first thing you always want to do is get rid of any addition or subtraction. So that means this 2b, I'm going to get rid of that first. So again, since that's adding, the opposite would be to subtract 2b from each side. So I'm going to do minus 2b on both sides. Okay, so now that means on the left I have s minus 2b. And again, you could put negative 2b plus s. It would be the same thing. And then on the right side, we have just p times h. Okay, and since we want to get h by itself, that means we're going to do the opposite here, and we're going to divide by p on both sides. Okay, so that way this goes away. So now we have s minus 2b over p equals h. Okay. All right, number 9. So solve for h. And again, on this one's a little bit different. So we have a equals half bh. Notice that this is your equation for area, okay, of a triangle. So half base times height. So this is essentially rearranging the area of a triangle formula. So on this, whenever you have a coefficient, which is what this 1/2 is, you want to go ahead and get rid of that first. Okay, so in order to get rid of a fraction, though, technically we are multiplying half times this. So in order to get rid of it, we would normally divide. But remember, when you divide a fraction, or divide by a fraction, I should say, you would typically do keep, change, flip, right? So if I divide by half, I would end up technically multiplying by the flipped version of 1/2, which would be 2/1, right? Which is multiplying by the reciprocal. So anytime you want to get rid of a fraction, like 1/2, you're going to actually multiply by the reciprocal. So you just flip that fraction. So we're going to do times 2/1, okay, which is effectively the same thing as just multiplying by 2. Okay, so you don't have to necessarily put 2/1 in this case because it is the same thing. So we're going to do times 2 on each side to cancel out this fraction. Okay, so now on the left we have 2a, and then on the right we still have base times height. Okay, and our goal is, again, get height just by itself. So now I want to get rid of b, and b is multiplying times h, so now I divide by b. Okay, so that cancels that out. So I have 2a over b is equal to h. Okay. All right, we got 2 more examples. All right, so number 11 says solve for L. Kind of the same idea as what we just did on number 9, right? So again, first thing we want to do is get rid of this fraction coefficient here. So again, you multiply by the reciprocal, okay? So since this is 1/4, technically we would multiply by 4 over 1. But again, since it's over 1, I'm just going to put times 4, right? You don't necessarily have to. If it makes more sense to you to put over times 4 over 1, go ahead. Okay, so if you want to just leave it as times 4 over 1, that's fine. But again, it's the same thing as just multiplying times 4. So I'm just going to put times 4. Whoops. 4, okay, on each side. Sorry, I don't know why it's not writing very well on this one. So times 4 on both sides. Okay, so now this 1/4 gets canceled out by the times 4, because we would get 4 over 4, which just equals 1, right? And on the left, now we have 4m. And on the right, we have p l. Right, and our goal is L by itself, right? Because we're solving for L. So now my next step is to get rid of P, and in order to do that, since it's P times L, I do the opposite. I divide by P on each side. So that's gone. And then on the left now we just have 4m over P equals L. Okay. So last example here. Solve for m. Okay, so we have ml plus b equals a. Okay, so on this one, we're just trying to get m by itself. Remember, if you have addition, so if there's two things happening, so in this case I have m being multiplied by l and m adding b. Anytime you have two things happening, you always want to get rid of addition or subtraction first. That means this plus b is what I'm going to get rid of first. And since it's adding b, I'm going to do the opposite. I'm going to subtract b from each side to cancel that out. So now on the left, I have ml. And then on the right, we have a minus b. Okay, and then our last step is to get rid of the get rid of the l, because I want m by itself. So I need to divide by l to cancel that out. And then I do the same thing on the other side. Divide by L. So M is equal to A minus B over L. Okay. And that is it.